In this video, I want to go over the risk return, or I should say risk-adjusted rate of return, which is a measure, of course, that was dealt with in this week's assignment. Plus, I'm going to take it one step further when we incorporate the value of a stock based upon the risk-adjusted rate of return. But first of all, if you recall from last week, you had to determine the current price of a stock. And the current price of the stock was based upon D sub 1, that's our dividends, divided by K minus G. Now, D sub 1 was the so-called expected dividend for the next time frame. Expected dividend for the next time frame. Excuse me, not the current dividend, but what we expect. K was the so-called required rate of return, and that is the requirement that you need to receive in order to make a purchase in this stock. So in this particular formula is what we refer to as the constant growth model. That is, G is 5%. That means our dividends are going to continuously to grow at that 5% rate. So keep that in mind. This is what we did last week. Well, what we can do, I can rewrite this formula in terms of K, in terms of the required return, and that would be K would be equal to our expected dividend divided by price plus G. So what we have here is, the required rate of return that you demand is based upon the dividend yield. Dividends divided by price plus the growth rate. So, required rate of return. Now, when we move on into the risk-adjusted rate of return, we can once again state K, or state the required rate of return as K is equal to what we refer to the risk-free rate plus the beta for the stock times K minus the market return minus the risk-free rate of return. Excuse me, I didn't do a good job on that one. But K. So all what we're doing is, you might say, we have two formulas from the standpoint of identifying the required rate of return. Dividends divided by price, dividend yield plus G, or the so-called risk-adjusted rate of return, which is the risk-free rate, and that is normally what we refer to as the rate of return on 90-day T-bills. The beta for the stock, how volatile is my stock in relation to the market? Say the Dow, the S&P 500, whatever it may be. And K would be basically what we expect the market to redo or to return. And then, of course, the risk-free rate of return again. So all what I'm going to go through here is looking at this K. And this is really what I've been made mention as the Jensen return, or the Jensen measure, okay? And I'll come back to that in a second. So once again, the risk-free rate, 90-day T-bills, beta, how volatile is my stock is to the market, and I have some information, of course, based on beta. And really what beta is, as I mentioned, is volatility. How volatile is my stock to the S&P 500? K sub M would be the rate of return on the stock market, S&P 500, and of course the risk-free rate of return. So I can put some numbers in here, and I can say, the risk-free rate is 1%, and that is the rate on 90-day T-bills. Plus I can say The beta for this stock is 2. And then I can say, oh, guess what? I'm expecting the market to return 10% next year. Again, expectations. We always value a security, a stock security, on what we expect, not what's actual, but what we expect. And of course, minus the risk-free rate, which would be 1%. So again, we can go through the confines. 1% plus, that would be 2 times 9%. So that's 18. So 19% is my risk-adjusted rate of return. Risk-adjusted, which simply means I'm taking into account risk of this stock. Risk? Oh, how risky is my stock? Well, that's kind of based upon this beta, the volatility. We know that all stocks do not have the same volatility as the market. Any stock that has a beta or a volatility measure above 1, of course, would be more volatile than the market. Any volatility or beta less than 1 would be less risky than the market. So kind of keep that in mind. More than 1, meaning the beta, we would have more risk for the market. Less than 1, our stock would be less risky than the market. So as I indicated, please keep that in mind. So how about this Jensen measure? What about this Jensen measure? Let's say the actual return. The actual. And here what I'm going to say is our so-called Jensen measure would be equal to the actual return, we'll say actual portfolio return minus the risk-adjusted rate of return, what we calculated, K. So from our standpoint, I'm just going to throw the figures out. Let's say we have our actual portfolio returned 22% minus the risk-adjusted return here of 19%, we would come up with a positive Jensen measure of 3%. I don't know if you can read that. Let me just kind of do that a little bit better. So let me go back and repeat this. Sorry about kind of the mess, but the Jensen measure, okay? The Jensen measure indicates if the portfolio, did the portfolio actually outperform the market given the risk the portfolio took, okay? Let me repeat that one more time. The Jensen measure measures, did the portfolio actually beat the market based upon the risk the portfolio took? So in this particular instance, the actual portfolio or actual stock, 22%. The risk adjusted for the market was 19%. So we had a positive 3% for the Jensen measure. And since it's positive, right, this portfolio did indeed outperform the market. So this was just a video I wanted to go over kind of that Jensen measure to explain more fully what we mean by the Jensen measure, what we mean by the risk-adjusted rate of return. Also from the standpoint that there are two ways to measure risk. Dividends divided by price plus G, or the risk-adjusted measure.